Okay, so we are going to be talking about quantum numbers now. We're not going to get into the nuts and bolts of quantum numbers. You're really just going to learn how to answer questions on quantum numbers. The questions that they ask on the AP test are very, very straightforward and easy if you know what each one of these numbers represents. On your paper or on the screen, you can see one example of a set of quantum numbers. So a set of quantum numbers would look like this: 4, 1, 1, 1/2. And the numbers can vary. I'll show you what they are in a second. But what you need to be able to do is tell what the 4 means, what the 1 means, what the other one, what the half means. And that will help isolate and answer any question they could possibly ask you on the AP test. So let's go ahead and start with the first number. Whatever number is listed first, in this case, it is a 4. Whichever one's listed first, that number is representing the energy level. Okay, now it's representing the energy level that the most valence electron of that atom is on. So these quantum numbers are telling you about the most valence electron for a certain atom or ion that you're dealing with. You won't be able to read this and go, oh, I know exactly what element this is, because it could be a neutral atom or it could be an ion. We just need to be able to isolate a little bit what's happening. So to tell energy level, this is a good review of our chemistry that we talked about last semester. To know what valence energy level we're dealing with, you just use the periods. So anything in this whole group is first energy level. This one has valence electrons second, valence electrons third, this one's fourth, this one's fifth, this one's sixth, and this one's seventh. Okay, so for the example we're doing, the first number is a 4. So that's telling us that our element that we're talking about has valence electrons somewhere on that fourth energy level. Okay, so let's go back to the problem. So for ours, we're on the fourth energy level. So if it was a 2, that would mean its valence electrons were second energy level. If it was a 1, valence electrons first energy level. Now the second number represents the sublevel. You remember you have energy levels, then you have sublevels, then you have orbitals, and then you have electrons in those orbitals. And really that's what these different pieces are representing. Now, what the sublevels are, if you remember, there are 4 types of sublevels: S, P, D, and F. What the sublevels, what this number is representing is that S, P, D, and F. If your valence electron in your atom is in the S sublevel, then this number will be a 0. If it's in the P, it will be a 1. If it's in the D, it will be a 2. And if it's in the F, it will be a 3. You do need to memorize those. Okay, you need to memorize those. So if we look at our example that we have so far, what we know about our example is that it's fourth energy level. You can tell that by the 4. And because this is a 1, I know that that means that it is in the P orbital. Okay, or in a P sublevel, I should say. Specifically in an orbital too, but P sublevel. So if you look back at your periodic table, we had already said that it was going to be somewhere here on the fourth energy level. Well, now we know it's in the P area. If you remember, these 2 columns are S, these 6 columns are P, that whole group. This block is D, and then down here, this block is F. Again, great review of all of this information. So what we now know is that we're fourth energy level and P block. So we know that our element that this 4, 1, 1, and 1/2 is representing is somewhere in there. Now past that, we're not going to be able to isolate it any further, but we do know it's one of those. If we go back, the next number, so this next 1 that we see here, that is representing the orbital. Now, that number can vary a lot, okay? It has certain numbers that it can possibly be. If it was an S-type sublevel, the only option for the orbital is a 0, okay? So if your second number is a 0, which this one isn't, but if it was a 0, then the only option for the third one is a 0. If the second one is a P, which is what we have right here, a 1, then your options are -1, 0, or 1. That could be the number that would be there. And you can see in this case, we have a 1, and it's followed by another 1. So that's logical. That makes sense. If it was a D, the options, there's actually, if you notice, you're going in order. S has 1 orbital, P has 3, D has 5. So D will be -1 or -2 or 0 or 1 or 2. Okay, those are the possibilities. Or if it's an F, it'll be -3, -2, -1, 0, 1, 2, and 3, like so. So, and you can see there's 7 of them there for F. Now, all you need to know are what the possibilities are. Okay, that's what you need to know for that. What they're going to do sometimes is ask you a question that says, which of the following is not a possible set of quantum numbers? And they might give you something like, say, 3, 0, 2, and 1/2. Now, we haven't talked about the 1/2 part yet. We'll get to that in just a second. But this is saying third energy level. Okay, so that makes sense. That's fine. We can have a third energy level valence electron. The 0 is saying that it's an S-type orbital. Okay, so third energy level in the S. And this is supposed to be representing the orbital in that sublevel. But if you look back here, if we're at an S, you can't have anything but a 0 for that orbital. So that would have had to have been a 0 here, which means this quantum number set cannot even exist. It is not possible. If your second number is a 0, the only possibility for the third number would be a 0. Okay, because that is all that's available. With P, if your second number is a 1, then your third number can be a -1, a 0, or a 1. With D, if your second number is a 2, then you can have a -2, a 1, -1, 0, 1, or 2. The way I remember these is, if you notice, it spans, you take the value of whatever the second number is, it goes from the negative of that number to the positive. So -1, 0, 1. This one goes, this is a 2, it goes from -2 all the way to +2 as possibilities. For 3, it goes from -3 all the way to 3 as the possibilities. Okay, so that's how you're going to figure those things out. Now the 1/2 right here, this represents, what is this doing? This represents the spin on the electron. The only possibilities you have for this number are 1/2 or -1/2. Those are your two possibilities, and it will never be your determining factor. Okay, all that is saying is that when you have two electrons in an orbital, they have to be spinning in opposite directions, which we learned before. So with all of this information, you should be able to answer your questions. Let's go ahead and just look at the first practice homework problem that you have for this. You only have 5 of them. There's really not that many questions out there, to be honest. Usually this will be like maybe 1 question on the AP test. But let's look at the first example problem that you have on your homework. It says, which of the following could be a quantum numbers for the valence electron in a potassium atom in its ground state? Okay, just meaning potassium, neutral, old potassium. So we find potassium on the periodic table. Okay, potassium is right here. Its electrons are 4th energy level, which means its first quantum number has to be a 4. So you look at your options. I'm just going to write A, B, C, and D, and E here. So we look at our options. Immediately we know A and B are not possibilities because they both start with a 3. For C and D and E, they all start with a 4. So they are still up in the air. Now potassium, the next thing we look at is what block it's in. So we look at our periodic table and we see that it's here in the S block. Okay, think about it. What number represents S block? You should have said 0 represents S block. So we come back to our options that we have here. This one, second one was a 0, a 1, and a 2. So we know that that's the right answer. That has to be the right answer because it starts with a 4, because this is 4th energy level, and it's in the S block. That was our only possibility. Okay, so that would be your answer. Notice, I only wrote the things I needed. I didn't even use the other numbers that were in all these problems because it's really a process of elimination thing. Usually you can answer the questions within the first 2 numbers. You should be able to get it off the energy level and what sublevel it's in, typically. Now there are some other examples in those problems that you'll see that work a little different, but you can, fiddle around with them and see. So go ahead and start the homework. Again, only 4 problems. Do those 4 problems, and as you're working, if you have questions, you can ask. Okay.